Hello everyone, my name is Nael. I'm a computational journalist and the creator of Code Like a Journalist, a free online open source course about data analysis and data visualization with TypeScript. In today's lesson, we are going to visualize data with the simple data analysis library and the plot library. Data visualizations help you understand your data and also communicate your findings. In this lesson, we'll learn how to visualize SDA tables from simple terminal charts to customized visualization with the powerful plot library. We are going to use the 2023 Canadian wildfires data. We used that in previous lessons, and we are going to explore different visualization techniques, including line charts, bee-swarm charts, and maps. This lesson assumes that you have already completed the tabular data and the geospatial data, so I won't talk much about how to wrangle data. I'll talk mostly about visualizing the visualizations that you can do with the SDA and plot. If you want to know when new lessons are available, subscribe to the newsletter, add a star to this course GitHub repository. And also there's a link here to get in touch if you have any questions. So let's start. We are going to use the same thing as the previous lessons to set up everything. So the setup SDA library, which I created, and this will install SDA, plot, and will also create all kind of files that will be useful for this project. So Dino -a GSR and Chub setup SDA. Here we go. One note about using setup SDA and SDA, it's best to have at least version 2.1.9 of Dino. To check your Dino version, you can run Dino -- version in your terminal, and if you need to upgrade, you can run Dino upgrade. So in this lesson, to keep our code organized, we are going to create two functions, one named crunch data, where we will fetch and clean the wildfire data, and another one named visualize data, in which we are going to generate the charts and the maps. So let's start with crunch data. In the helpers folder, you can create a new file, crunch data. And I'm just going to copy this, but you can type it if you want. So the function here, we are exporting a default async function crunch data. It will, the first and only parameter here will be fires, which will be a simple data table, a simple table. And in it, we are fetching data for the 2023 wildfires data in Canada, and we are caching the result exactly like we did in the previous lesson. Now we can create a second function called visualize data, and for now this function is also, this file is also exporting a default async function that will also be expecting a table, fires, a simple data table. But for now, we're just logging the table. We're not doing anything in there. And finally, we can update our code here in main by creating a new table, SDB, new table, fires, and we can call crunch data with the fires, and then we can visualize data with the fires table. I forgot to run Dino task SDA, so nothing is happening. But now you can see that the data has been fetched and inside crunch data, and then visualize data has been triggered, has been called, and we have the result. So the data here is a slightly modified version of the data that we used previously. You can see that we have a start date for the fires, We are going to use that for our data visualizations. But the rest is pretty similar. We have the hectares burned, we have the cause of the fire, latitude, longitude, and the provinces. So maybe we have around 5,000 fires as well. So maybe the first visualization that we could do would be how much wildfires have burned through the year for each province. And to do that, we need the cumulative sum of the area burnt per province. So inside Crunch data, we can start by summarizing our data. We could summarize the data per date. So the values that we want to summarize are the hectares. The categories will be, well, the province, because we want the area burnt throughout the year per province. And the second category first would be the start date, because right now we have a lot of fires. Some of them have happened on the same day, but they are a single row right now in our table. So we would like to know, hey, on a given date in a given province, how much have burned. The summary, so it would be a sum. And for the decimals, we could keep just one. Okay, so now you see we have one row per day, and we have the sum of the area burnt on this day on this province. Now what we can do is use the accumulate method to then do the cumulative sum row per row. Summarize is already sorting our data. So we have all of the dates for Alberta, and all of the dates are ordered ascendingly from the earliest date to the latest date. So we can use accumulate directly in here. So fires, accumulate. Accumulate needs to know the column where the values are and where the new cumulated values will be stored, so cumulative hectares. And also we want to do that for each province. So we need to specify province. Oh, and maybe we can round as well. Here we go. Cumulative hectares, and let's keep only one decimal. Okay, so now for each province, we have the cumulative hectares burnt throughout the year. So we start here in Alberta, we have this area burnt. Then on the second date, we have this, but we do the cumulative sum, then this, so we add to the rest, etc., etc. And we are doing this per province, right? We have the categories province and categories province here. Great, so our data is ready. Now we can visualize this. So if you want to visualize data with SDA, you have some very easy methods that you can use to log charts directly in your terminal. For example, here we could do a log. We could use log.chart. So let's use it. Wait, fires, log.chart. So the X value will be the start date, and the Y values will be the cumulative hectares. So when you use log.chart, this will create a chart directly in the terminal for you. But of course, we don't want a big chart like this one. Our data is per province, so we can use a few options to do multiple charts, one per province instead of just one big chart. For that, we can use the option small multiples with the province. We can also add a few things. For example, it would be great to have the same scale shared between the charts, so it will be easy to compare provinces. And just to show you a few things, we can also format X or Y values. So for example, here you can see that this number is pretty hard to read. So you can pass in a function to format it. When you install everything with Setup SDA, you have a library called Journalism that I also created that is available and that you can use. And in it, you have a lot of helper functions like format number, for example. Here we need to help TypeScript a little bit with an explicit type. And we could format the number, for example, with just one decimal, and it would be great to have a suffix to know that it's in hectares. Here we go. So the log.chart function is creating charts for each province. So you can see that we have Alberta here, British Columbia. You can see that the scale is exactly the same for all charts, which is nice to compare provinces. And yeah, so you have access to log.chart, log line chart, log bar chart. There's also log histogram to log things quickly in your terminal. But obviously these methods are quite limited because you are in the terminal. We can create more interesting visualizations with plot, and plot works really well with SDA. So you have the GitHub link to plot. If you have a GitHub account, add a star. It's an amazing library. It's been created by Mike Bostock, and Philippe Rivière is a major contributor to the library as well. It's open source, of course, and it's based on D3, which is a very famous data viz library that has been around for quite a while and that is still used very widely. Mike Bostock created D3. But it's way easier to use because there's a lot of things with D3 that you have to do yourself, like the scales, the axes, etc., etc. Plot will do a lot of the work for you, and you can just customize what you want to customize. When you installed everything with Setup SDA, you installed Plot as well. So it's very easy to use now. Let's start with this here, this code here, and I'm going to explain to you what's happening. So this code here creates a chart in output chart. I'm going to put it below my code, split down. So that's something very nice with, and I'm going to toggle the terminal. Here we go. That's something also very nice with VS Code. You can set up your tabs in any way, any layout that you want. So here we have the code above, and you can see that we have the chart below. Okay, so let's talk about plot and how it works and how it works with SDA. So here in visualize data, before we had just fires.log table, which is logging the table. But now we have another thing. We have a function here, draw chart. This function here needs some data. The function doesn't know what the data is, except that it's an array. And that's enough for plot to work. In our case, we know that our data is actually an array of objects because this is what SDA will pass to this function. The function returns a plot chart. And you can see that we are importing the plot function here. The plot function will draw the chart, but it needs a few options. It needs to know what you want to draw. The options are stored inside an object, as you can see here. And in this object, the most important thing is the marks. The marks are the shapes that you want in the chart. The marks are stored inside an array because you could have multiple shapes, dots, lines, etc., in the same chart. And each mark is created by a function, a plot function as well. So here I'm saying, hey, I want to create a line chart. This is what we have in the marks array, a line chart, because I imported the line function. The line chart, I want it to be based on the data. It's the data that is inside the table, because fires will pass the data to the draw chart, and this chart will be used. And then we have a few options for the line as well, so it's an object again. The X value, I want them to be the start date. The Y values, I want them to be the cumulative hectares. And the stroke, the color of the stroke of the line, of the lines, I want it to be based on provinces. When you do this, it also means that each line should be a province, because each line will be a different color based of the value inside provinces. And so if you use this drawing function inside right chart needs two parameters, the drawing function that is just here, and a file path to decide where should this chart should be saved. It will create this chart that is shown below. So this is very simple to create this chart. Of course, it's quite basic. There's also a few problems, including an issue with our y-axis, but that's usually how we start. We just drop a shape that we want inside the marks, and then we start iterating to improve the chart. So let's improve the x-axis. So to improve the y, I said x, the y-axis, we have access to a key y directly inside the options for plot, and it's an object as well. And in there's a few things that we can do. For example, we could add a grid to make things a little bit easier to read. So you see that we are watching main. I toggled the terminal, but the terminal is still running, right? So we are still watching main. So when I saved visualize data to add the option grid to true, Dino knew about it because visualize data is a dependency of main, and we are matching main. And it rerun the code, and we have seen the chart being updated. So it's a very nice setup to work as well. So we have our grids now. Something we could do is to update maybe this label at the top. So it's the Y label, area burned hectares. Here we go. It's updated. We have probably too many ticks. We can just ask plot to use just 5. And right now, the numbers for the ticks labels are huge numbers. Maybe instead of showing hectares, we could show million hectares. So for that, we can use tick format, and we can pass in a function. Here it's an arrow function. D here will be the number that is being used. So we can use backticks to say, hey, just grab D divided by 1 million. 1 million, and add a capital M after it. And so now we have a way better y-axis. We could add extra space between the last tick and the label. You can also add an inset for the whole chart. Here we go. Much better. With options like this one, you can really customize your charts in any way you want. We could add a few more things. Maybe we could update the X label. So we can do the same thing, label. We can call that date. And it would be great to have a color legend. So we could use the color option and say, hey, we would like a legend. And maybe we want a different color scheme. So you have a lot of available. Let's use a Tableau 10, just for the sake of the lesson. So this is how you can update colors as well. But you can see that we have many provinces and that it's not very convenient to have this color legend like this. This could be improved. Maybe one strategy would be to have a dot at the end of each line and a text label to tell you which province it is. So let's do that instead. So after our line mark here, we can add another function called dot to create dots. And it works the same way. We pass in our data and then we pass options. So we don't want to create a dot for each point, right, on the line. We just want a point on the last data point here. So we could use what is called a transform, select last. This here will grab the last data point. And you can pass options to that. So X would be start date, Y would be cumulative hectares like for our line, and the fill of the dot would be province. We can also remove our color legend. And so you can see that we are drawing a dot on the last data point of the data for each province with X and Y values. And you can see that we have a dot at the end of each line. Now we can do the same thing, but for the text. So after our dot, over here, after a dot, we can add text. And by the way, this is all imported directly from observable plot. So we can add text. And again, it's the same syntax. So first we pass the data, it's still the same data. Select last, because we want just the last data point. And the start date would be the X value. The Y would be the cumulative hectares. Here we go. And we can add a third dimension, which is Z, just to tell plot that we want to do that for each province. When we use the fill or the stroke, it was inferred by plot that we wanted to do this for each province. But here we are going to draw the text in black, so we need an extra dimension. So if you draw just this, you're going to see some values. By default, it's using the hectares values, but actually what we want, the text that we want, is the province. Here we go. And now we can adjust a few things. So first we can specify that we want black. I think it's already black, but well, I want to follow the lesson. Something that I like to do is to specify black, and I want to specify a stroke of white. When you do this, it adds a stroke around the text, which makes the text way easier to read when there are overlapping elements. Now, we would like to have the text aligned with the dot, so we can use a text anchor of start. Here we go. Now it's aligned with the dot on the left. But we don't want it to touch the dot, so we can use dx, and maybe we can shift it by 5 pixels. Very nice. It's taking shape. So now our chart needs some obvious updates. So first, we can see that the labels are not aligned. And this is because we summarized data based on the fire's start date. Some provinces have some gaps in their dates. They're not finishing all at the same time. It would be great to fix that. Also, we can see that not much is happening before mid-April, and nothing much is happening after October. So maybe we can filter the data as well. So in Crunch data, the first thing that we can do is to summarize, to filter our fires. And the start date should be greater or equal to mid-April. And the start date should be smaller earlier than October 1st. So that's the first thing that we can do. So we're using more room to actually something that is happening. And then what we would like to do is to have the same final date for all provinces. So something that we can do is first we could extract, and let me log this so it will be easier to understand. I'm just going to remove that for now. So the first thing that we could do is have the max values for each province. We are summarizing the data, the fires data, on the cumulative hectares, and we're doing this for each province. We are retrieving the maximum value for each province, which should be the value at the top right side of our chart, right? And we are outputting it inside a new table. So you can see here, these are the maximum burnt areas for each province. Now we can clean up this table to match the fires table. So we remove the column value, we rename the column max cumulative hectares, and we add a column start date. So now we have rows of data showing for each province the cumulative hectares, and we are forcing a start date of October 1st. And so now we can use this data and just insert it inside our fires. And I'm not sure we are, oh yes, we are logging the fires. And so now we have the max date with the maximum cumulative hectares burned per province inside our fires table. And if we check our chart now, down, here we go, and I can toggle the terminal. And so now you can see that all provinces are perfectly aligned. This is taking shape. But we have another problem, right? We can see that we need a margin right, a greater margin on the right side. So we can use the margin right option. Here we go. And also we can see that we have some overlapping labels over here. We can just quickly filter the text with the filter option in the text mark. We can do the cumulative. Since our data inside the drawing function is an array of objects like we had before, we can just retrieve the value for cumulative hectares and say that we just want to display the text values for when the data point has 400,000 hectares burnt or more. And so now you can see that we remove the one below. There's other text techniques that we can use to avoid overlapping labels, but here I just wanted to show you the filter method and keep things fairly simple. And that's our chart. Pretty nice, right? So we worked inside Crunch Data to crunch our data with SDA. And then with visualized data, we created a drawing function with plot with its very nice syntax and its very useful marks and transforms and options. And we just passed it to SDA, to the table that we wanted to draw to create a chart. So now this chart is fairly traditional. It's nice, but it's quite traditional. We can do more uncommon, more innovative visualization with plot and SDA. So for example, we could create a wildfires bee swarm chart. So let's draw this bee swarm chart now. We are going to update a few things in our code. So first, we don't want to summarize our data anymore. So we can just grab our fires data and just filter to keep only fires that have burnt more than 1 hectares. This is already quite a lot of fires, around 2,400 fires. In our bee swarm, we are going to visualize each fire individually. So this is already quite a lot. So we are going to work with individual fires from now on. And inside our visualized data now, we are going to start by just showing dots on a y-axis. And so now, if we do split down, so you can see our fires now are visualized as simple dots with the y value being the hectares. So just one axis. And you can see that right now they are pretty much all overlapping. This is why a bee swarm could be quite nice because it will try to place each dot so they don't overlap. We can use dodge X, which is a transform. And this dodge X will try to, on the X axis, to place the dots so they don't overlap. So let's see what's happening. By the way, dodge X is quite computationally expensive. So depending on how fast your computer is, it might take a few seconds. So I forgot an option. So it's dodging X on X, all of the fires, but actually I want it to be in the middle. So let's add the option middle. Here we go. And so you can see that now we are seeing each fires individually. There's so many small fires that it's actually going outside of the bounds of the chart. It also looks like we have a few very big fires and a lot of small fires. So something that we could do in that case is to use a log scale, a logarithmic scale. With plot, you have the ability to use a lot of different scales. So we can change our Y scale option and say, hey, I want a log 1. And that's already much better. So you can see that we have a logarithmic scale now. And we are seeing way more dots. Another improvement that we could do is to scale the dot radiuses based on their fire size. So to do that, we can use the R for radius on the hectares values. Much better, right? We can also use the R option at the top to specify a range. So let's say that we would like the dots to have a radius of at least 1 and a maximum of 20 pixels. this is looking better. So we are starting to see something. Something that we can do as well is to use the cause to color our dots. So for the fill of the circle, we can use the cause, and we can add a legend, color legend, true. Very nice. It's looking pretty nice. But it's still very hard to compare visually the different causes. So maybe we could create facets. Instead of having one big chart, we could create one chart per cause. And let's say that we would like to do that horizontally. We can use fx for facets on the x-axis. And we can say, hey, actually we want to do that with the causes. Here we go. And maybe we can make the chart a little bit larger and increase the width to, let's say, 800 pixels. Very nice. This is looking great. We can remove the color legend. We don't need it anymore, right? Because we have the labels for each cause. We can maybe, if we remove the color legend, we could add a margin top. So the biggest circle won't touch at the top. For our y axis, maybe we can rename it hectares. 5 ticks would be enough. And let's add grids like we did before. Much cleaner, right? And we don't need the cause label here. So for the facet, we can remove the label. Label just null. So we won't have any. And this is a very good looking bee swarm chart with facets on the cause of wildfires. And you can see how step by step, by iterating, we've been able to tweak the chart. The code is fairly small, and this is a quite good looking chart that you don't see very often, even if it's actually very efficient visually to show this kind of data. The data is stored in the chart.png file. As we worked, the file has been rewritten and displayed on VS Code, so it was very convenient to work this way. So we worked with fire data as tabular data, right? Just columns storing values, numbers, but we can also create very interesting maps with SDA and plot. SDA works great with tabular data and geospatial data, and plot can create 2D charts like this one, but also very, very nice maps. So let's do that now. In the crunch data, we can update our code to fetch a few more things. So let me close this. So I just copied and pasted the code from the lesson. So we have our fires as before, but now we are creating point geometries like we did in the geospatial data lesson. And also I'm adding a column for the fires, is fire, which is a Boolean, and it is always true. So the fires will be easier to retrieve later on. And I'm fetching also the province, the Canadian provinces boundaries, like we did in the previous lesson. Now, when you want to create a map with different geometries, so here we want to create a map with the fires, but also the province boundaries, you need to have to put all of this data inside one table. This is how it works. So after creating the points and the is fire column, and after fetching the provinces boundaries, I'm inserting the provinces inside the fires table. And because provinces and fires don't have the same columns, I'm just passing the option to tell SDA, hey, create the missing columns if there's any. Now in visualize data, so let's save this. In visualize data, we are just going to log the table for now. And finally, we can update main. One thing that Crunch data is doing, and I forgot to tell you, is that it's expecting two tables now, one for the fires and one for the provinces. So in main, when we update everything, compared to before, we are creating a new table, provinces. And Crunch data is now expecting the fires and the provinces to fetch the data for each table and finally to insert the provinces inside the fires table. But for visualize data now, since the provinces are inside the fires, we can just use fires. And so when we visualize, when we just log the table, this is what we're seeing now. We have each fire with all of its information. And we have, yeah, and at the bottom, actually, we have, let's log, let's say 10,000 rows. We have just, oh yeah, it's not like this, it's number rows to log. Let's say 10,000, so we have everything. Here we go. So you can see that we have our fires, and then at the end, we have the provinces. So now the provinces and the fires are in the same table. Cool. We can start by creating a map. So for the map, we are going to create a new function called drawMap. And this function will expect data. But now the data format is a little bit different because we are working with geospatial data. So SDA will pass a GeoJSON data to drawMap. And so the type of data is a little bit different. It's a GeoJSON, so we are expecting a features array, and inside each feature, we are expecting the data to be inside the properties key, with each key being a string, and the data, we don't know what it is. So this is a little bit different. By the way, you don't have to write that every time. If you do fires write map instead of write chart and you hover over it, you have examples and you can just grab the code either from there directly or directly from the examples. So that's our function here, drawMap. WriteMap will need the drawMap function. So it will pass the GeoJSON data, the geospatial data from the fires to drawMap, so we can draw the map that we want. And we are going to write the map inside the output folder as map.png, like this. So right now it's not doing anything because we are not calling and returning plot. And plot needs a few options inside the marks array, right? Like before. So for now, it's not doing anything. And if we check our map and we open that below, and we can hide the terminal for now, you can see that there is nothing as an image. We want to draw our fires and we want to draw also our province boundaries, and we don't want to style them the same way. So something that we can do here first is to keep them in separate variables to draw them later. This is why we added the isFire column in Crunch data. So first, let's grab our fire points. So our data is a GeoJSON, which means that there's a features array. So we can use filter on features, and we can filter everything by saying, hey, inside the feature, there's properties, and we want the property is fire to be true. When this exists, just put the row, the feature inside the fire points. And so now all of the fires will be stored inside this variable. We can do the same thing for the provinces polygons. So in the data, look for the features and filter each feature, and feature properties is fire. So I'm doing exactly the same thing, except now there's an exclamation mark, which means, so here this means, hey, if this exists or is true, keep it and put it inside fire points. This here means, hey, grab this value, and if it doesn't exist, if it's undefined or null or false, put it inside province polygons. So now all of our fires, which have a column is fire and the value is set to true, will be inside this variable. But the provinces polygons, they don't have a true value for is fire, so they will be stored in there. And so now we can easily use these variables to create our map, to map them. There's a mark that is specifically for geospatial data with plot, and it's called geo. And by the way, I automatically imported it here by pressing enter when VS Code suggested it to me. And so now we can draw our geometries and our points. So the first thing that we want to draw, it's the provinces, right? And on top of our provinces, we want to draw the fires. And now you can see that plot just created this map. The provinces are polygons, so plot created polygons. The fires are point geometries, so plot used dots. Pretty clever. But of course we can improve that. The first thing that we can improve is the projection. So this is a Mercator projection, I think. We can use one that is quite better for Canada with the projection option. So we can use a different type, which will be conic conformal. So that's better for Canada. So that's the result by default. We can rotate the projection so it will look better for the country. Here we go. You can see that north is pointed north now, pointed up. And finally, we can specify the domain. So plot will make sure that our geospatial data is full width and full height on the map as much as possible. This is looking way better. Now we can style our provinces. So as we did before with the other methods, first you pass the data and then you have the options. So here we can say, hey, I want a stroke light gray for the provinces. I want a fill of white smoke. So we just want the provinces as a subtle background, right? And for the fires, so by default, Geo is creating dots, but we can have anything we want. One thing that I like on this kind of maps is spikes. So we can use the spike mark, and we can pass a few options here. So for the X value, it will be, we need to pass a function because we need to tell the spike function where to find the values inside the features, since we are working with geospatial data, the values for the X scale. Our values, since we are working with GeoJSON features, are inside the properties, and the X value will be the longitude, the Y value will be the latitude, and we need to specify a length, and we want the length tied to the hectares. This is looking quite cool. We can tweak the length by specifying a range. So let's say that we would like a spike of at least 1 pixel and maximum 100 pixels. Pretty nice. We can also add a stroke based on the cause. And we could add a color legend. So outside of the mark, we have access to the general options. We can say legend true. Look at that, a spike map of Canadian wildfires. This is getting quite good. But there's a problem, right? You can see that we have a lot of overlapping spikes. There's a lot of fires, and right now it's quite confusing visually because there's so many overlapping spikes. By default, plot will draw the spikes in the order that they are in the table. So we can tweak that to have a 3D effect. We could go inside Crunch Data, and we could sort the fires by latitude in descending order. When you're doing this, basically you are saying the latitude is on the y-axis. When you are up north, you have a high latitude. When you're going south, you have a lower latitude. So when we are ordering the fires by latitude descendingly, we're saying, hey, I want you to draw first the fires that are up north, and last the fires that are down south. And this will give a nice 3D effect. It will give some perspective to the map. But there's another problem. You can see that we have transparency, right? We have a little bit of transparency on the fires. By default, plot creates this transparency. Oh, I clicked on minus. Okay. By default, the spikes have some transparency. It would be much better to have a fill opacity of 1, which means opaque, like this. But it would be great to keep the paler colors for the interior of the spike. So we can do that with by passing a function that will check for the cause for the fill. Here I'm saying, hey, I want to change the fill of each spike. I want you to check the cause. If the cause is human, I want this color. This is called an X color, hexadecimal color. If it's natural, I want this color. Otherwise, it means that it's unknown and I want this color. These colors, I just created them by grabbing the color in the legend and by adding more white to it. If you want to know more about X color values, there's a link for you. There's a lot of ways to represent colors in code, but this one is quite common. And so now, if you check the map, you can see that we have our 3D effect, and the spikes are now opaque, and it's looking quite nice. Maybe one extra thing that we could do, I think I'm doing it in the lesson, yeah, is to increase the range here. Instead of 100 for the maximum length of the spike, we could do 200 to have something more dramatic. And you can see that we have our map now that is looking really nice. And we've done all of this with SDA and plot. And look at the code for plot. I mean, yes, we are tweaking a lot of things, but it's fairly short. It's crazy that you are able to create a map like this with just these few marks and transforms and options. One thing to add, if you want to export this map as vectors, so you can just output it as an SVG, and this SVG can be imported inside Illustrator, for example, to tweak it, to add labels, and yeah, to adjust it to your publication needs as you want. And so that was, I think, our last example. It's already time for the conclusion. So data viz is a big topic. Here we created 3 charts together, a line chart, a bee-swarm chart, and a spike map. There's way more things that you can do. I invite you to check the GeoMark documentation. You'll have a lot of explanations and examples. The projections documentation as well. You'll see everything that you can do with projections. There's also, I think I skipped that, but there's also documentation for marks. So you have a lot of examples for the marks over here and over there. So you have all of the marks available with code examples. Go check them. It's pretty amazing. Same thing for the transforms. So for example, you can see the one that we use, the select, is over here, but you have way more. And you also have a plot gallery that is updated quite regularly with a lot of very interesting examples, and all of the code is open source and available, so you can easily replicate everything that you're seeing here. That's it for the lesson. I hope you enjoyed it. The combination of simple data analysis and plot is quite extraordinary, in my opinion. I love to use this library, these libraries to do my projects. Of course, here we are just saving charts as images, so there's no user interactions, there is no animations, but don't worry, everything that we've learned so far, we will be able to reuse it on the web to create interactive, personalized data visualization in future lessons. If you enjoyed this lesson, subscribe to the newsletter, add a star to the GitHub repo, and see you soon.